Hey everybody, welcome to the SEMA FutureTech live stage. This is our third and final session topic on electrification today. And we're ending with a topic on the future of electrification and how we get there. So we're going to be focused on technology in this conversation. And we're going to be talking about the technology with the minds behind a lot of what you see out here in the FutureTech live zone today. So in just a moment, I'm going to welcome these panelists up. My name's Maverick Knowles. I'm the president and co-founder at Legacy EV. Honored to be able to introduce these sessions in the electrification stage today and share it with some of the industry's best. So I'm going to bring them up here one at a time. It's kind of a small stage, so forgive me as we maneuver around each other up here. But first up, I'm going to bring up Eddie Borshevitz, the founder and CEO of Revol. And Eddie, if I got that last name right, you're going to have to... All right, yeah, you'll have to correct me. Apologies, Eddie. Go ahead and take a seat on the far side there. Next up, I'm going to bring up Kirk Miller from Hypercraft. Thanks, Kirk. Kirk was also at AEM previously, now the VP of Sales at Hypercraft. Industry knowledge between these two is immense. Excited to hear what they have to share. Third up, we're bringing up Chris Hazel from Felton. Felton is a UK-based electric vehicle conversion company. Sharing the stage here at SEMA this year. And third is Lawson from Amper EV. They got a great booth right behind you guys over in the FutureTech stage. And moderating the panel for these four brilliant gentlemen today is Rob Ward, CEO and founder at Legacy EV, a good friend of mine. Excited to share the stage with these gentlemen. If you're interested in hearing about the future technology of the EV space, come take a listen. We'll be here for 30-ish minutes.
Thank you, Maverick. So I'm gonna sit in this very uncomfortable chair. You guys all got the same chairs, I guess. Congratulations on your padded chairs.
Thank you.
Okay, so today we're gonna be talking about a handful of different items in the EV, e-mobility movement. We're gonna be talking about safety. We're gonna be talking about shops, staffing and tooling, and we're gonna be talking pricing. So yeah, I'm just gonna, ask some questions to the people on the panel here, and looking forward to hearing your guys' thoughts on these items. So I'm gonna start off with Kirk. Kirk, what are some of the upsides to EV conversions, and conversely, what are some of the downsides of an EV conversion?
Thanks, Rob. So upsides. This is depending on who you are up here, but I think most of us are in a common mode. We're in search of increased performance. There are some green components that go along with this, but the focus really is performance. So the upside is A, performance, and then B, in America, depending on where you're from, and probably around the world, there's some headwinds and tailwinds. The headwinds are the ARB and the EPA cracking down on modifications to the performance that's done to an engine that has emission control devices on it. It's illegal. So that's a massive, massive headwind and challenge. Now, it's a tailwind as well for the conversion market, or people who are interested in this segment, for A, increasing performance, but B, you don't have to worry about legislative and regulatory issues that could chase you in the event you're making these modifications. So, yeah, so the upside ultimately is the performance benefits and lack of freedom to do what you want. So that's your upsides. The downsides in the end, there's definitely cost barriers that we have to overcome because this is a newer segment. The economy of scale really isn't in place yet. We're all working toward that. And then also reducing and engineering. Everyone up here is doing the same thing. We're trying to reduce and engineer the complexity out of these systems so it becomes more of a plug and play or turnkey package for you, ideally chasing the 5-key or the 5-wire program, so you could just have a system and then it's up to you or the builder to integrate it into the vehicle. But the system itself is already engineered end to end. So the cost barrier is the challenge, and the performance benefits and lack of oversight is definitely a huge benefit.
Oh, thank you on that, Kirk. I like to add when we're talking about the market as a whole, EV technology is an expansion of the total addressable market. So for any companies out there that there are people coming into the aftermarket industry that are excited about an EV that weren't in this industry before, and think about how that benefits a custom wheel manufacturer or painters or window tint, or when the total addressable market grows, just because you're introducing another technology that a new demographic is getting excited about. That's something that as a whole we should all get excited about. Anybody else want to say anything on pros and cons of EV conversions?
I'll just chime in when you're saying TAMs, the total addressable market. I spoke earlier today and I was sharing some information. I really wanted to frame the opportunity for people who are actually interested in this. I just talked about the headwinds, the EPA and the ARB cracking down on us. The fact of the matter is that the market segment, just the global crate motor market segment, 2022 was $23.5 billion. It's forecasted to run at a compounded annual growth rate of 5.5%, which means it's going to be $36 billion by 2030. To me, that's fascinating. And that gives you just a glimpse inside of what the opportunity is. So the upside is massive. If you just take 0.5% of 2022's numbers, that's $114 million. That's insane. That's fun. So that's definitely upside of the market opportunity.
Absolutely.
You forgot about one of the main downsides here.
Oh, you're going to hit us with the downside?
Well,
okay.
The noise is gone.
Oh, okay. Yeah.
Like most people here are clearly thinking that. Like
Yeah.
the V8, the V10, the supercharger, the turbo.
Okay, listen, I want to speak to that for a minute. So, been hearing that from day one, right? Oh, but what about the noise? You need a speaker. And I would, in the early days, I would roll my eyes. I'd be like, and then, bless her heart, Holly High Voltage, I go to this all EV event. We've got drag racing, we've got autocross, they're running cars on the track, and it's just, and I was like, okay, I miss the noise camp, like just the vibration and the noise. So if we were on this panel 2 years ago, I don't know if I would have agreed, but I've now been entrenched in the EV side enough that I'm like, yeah, the noise. So.
They're not really silent though, are they? They have a noise to them. It's a different noise profile, but it's not silent. When you get on, you do hear kind of that futuristic, whirring whine where you can tell it's doing something. It's just that it's not that rumbling V8 sound profile, right?
Yeah, that's a true disclaimer. It's not silent. It's
deadly. I mean, to go into that, I mean, it's deadly. It's silent but deadly.
Yeah.
To segue off of that, I grew up around racing motorcycles and V8s and everything else in my life. And a few years back, I bought my first electric motorcycle, which was an Alta, and it took a little getting used to, obviously. But there was other audible components to that we didn't hear ever because we grew up on very loud engines. Now I could hear the substrate underneath my tires. I could tell when my tires hitting gravel versus sand versus hard pack. And it's like being at a concert your whole entire life, and all of a sudden the music stops and you hear everything else going on. And at first it's almost a sensory overload on my end. And I'm kind of applying that with my cars. I could hear the tires differently. I could hear the suspension working. I could hear the frame twisting. So to me, it's not just a downfall because, yeah, I do miss the sound. But there's other sounds that I'm starting to learn that are making me more aware of what my machine is actually doing. I just recently got back on a dirt bike that actually had a 450 in it. And I didn't miss it. I didn't miss it because the vibration, I was like, well, I remember feeling now my tires and all this other stuff going on. Yeah. And once you feel that and hear it, it's a totally different game changer.
Yeah, totally. Well, is that my mic? Check. Chris, my next question's for you. Let's talk a little bit about, are EV conversions the future of the aftermarket? And if so, where do you see the EV conversion market being in the next 5 years?
That's a good one. Yes and no. There's going to be people on both sides, I think, here. So we've done, in the UK, we've been looking at EV conversion for the aftermarket and also alternative fuels as well. So there will still be a place for racing and F1 and drag racing and all that stuff with a combustion engine in. And I don't think anyone here wants that to ever go away. Younger generations might, though. But what we're seeing is a completely different demographic now coming into the market, which, to be honest, a lot of them probably aren't here today. It's the generation, the younger generations, even younger than me, that love the way classics look, but would never own one because they don't know how to maintain them. They don't know how to change the oil. They can't look at their app on their phone and see what the car is doing. Like, there's a generation growing up like that now, which would never own a classic vehicle. So by us doing these systems, these kits, these developments, we're allowing a whole new demographic to come into the industry and keep classics living on into the future. And that then leads us on to where is it going to be in the next 5 years? The only way for us to make this accessible in the next 5 years is the company sat here today is how we can design, develop, manufacture systems cost effectively to bring the pricing point down, to make it accessible to all the other generations that are out there, because it's still very expensive, which I'm pretty sure one of you guys probably will jump in on that, because you're doing similar to what we're doing. How do you make modular systems to bring the pricing point down?
Yeah, and how do you scale it up to make it available to everyone too, right? So it's pricing, it's availability, it's getting it to where it's easy. And Kirk touched on this earlier. Everyone here is all about how do we make it easy for people to adopt these EV drivetrain systems. And I think everyone has these challenges that they're trying to solve that improves the price a little bit, maybe improves the install a little bit, all while keeping those benefits of the EV drivetrain.
Yeah, and then the other big thing that's got to come along with that, which is also what Legacy are doing massively, is enabling multiple options for people, but also the training that goes with it. Because people are scared of this stuff right now. I think we all live with it day to day, so none of us are scared of what we're doing. We understand it, but there's so many people out there that look and just see orange cables and are like, can't touch it. It's going to kill me.
Yeah, we've put a lot of energy into occupational need studies to understand out of the 660,000 current automotive technicians and the rate at which OEMs are pumping out electric vehicles. It's not just about service and maintenance, collision. Things happen to these cars that we didn't plan on happening, and even though they require less maintenance than ICE vehicle, the demand for technicians is staggeringly high. And then beyond the technicians, it's also everybody who comes in contact with the vehicle from a safety. From a electric safety, high voltage safety standpoint. So segues perfectly into my next question, which I was going to start with you, Eddie. How does safety influence your approach to manufacturing? Oh, hold on. That's my next question. You didn't hear the whole thing, so just what are some of the safety concerns associated with EV conversion? So I want to talk specifically about repowers and what protocols we need to have to make a safe electric repowered vehicle.
Yeah, I mean, there is something inside the electric cars called electricity that we can't smell, we can't see. With gas cars, that was pretty easy. If you smell gas, you usually wouldn't light up a cigarette. But with the electric side of things, you don't know until it's too late. Yeah, you could feel it, but by the time you feel it, it's already got you. One of the main things I see, especially with the high power vehicles that we have, is everyone thinks high voltage is what kills you. Well, no, it's actually the amperage behind it. The type of amperage that these vehicles put out is tremendous. I have a Mustang back there. It runs at 1250 amps DC. That could power a small block of houses. Also with amperage comes heat. And those are the things of a perfect recipe that are going to either destroy your car, burn your house down, and blow things up, because, that's where it comes from. But you can't see it, you can't smell it. And also, we're dealing with these older vehicles. We're not dealing with OE products here that have been designed by companies that are worth billions of dollars. Some of this stuff is being designed by much smaller companies like some of us. And the challenges of fitting this into older vehicles it's big. And to do it safely and to do it right takes a lot of forethought. In the very beginning of this industry, I think all of us could attest that there's a lot of Band-Aids and a lot of, bubble gum stuffed in places where we wouldn't do that now, because we realize what happens if you do that. We've seen cars burnt down, we've seen people get hurt, And we don't want to see that moving forward. It's a huge blemish on our industry, especially. I do a lot of racing. We do Bonneville. We built the fastest electric car a couple years ago. It's actually outside the Magnafola booth in Optimum Batteries. That car did almost 360 miles an hour. My biggest concern wasn't going fast, is what would happen if that battery caught fire. That guy cannot pull over at 360 miles an hour. He has to slow down first. And the timing of that, and how do you build these systems to prevent any kind of catastrophic human loss at that point? So the forethought that has to go into that is timing. Okay, how much time does it take? Because once these batteries do go up, there's no way to put them out. They have to just basically expel their energy and slowly kind of burn it off. So what do we do to mitigate that time between something going wrong, alerting the people that are inside of it, or the people working on it? All of us have shorted out a battery here. It's not fun. I've seen people drop wrenches and stuff, and the wrenches vaporize. I mean, 10 mil wrench, it's gone in a split second. I've seen it happen myself. So mitigation of a lot of this safety for these people, I think, is a number one concern for us at the office. We always have interns coming in, and the first thing I do is, these are the batteries, don't touch it.
Yeah, I like to talk about like the line of delineation between, the actual exposure to the risk, because there's certain tasks that are done in battery manufacturing and things that need to be done where there's a present risk that's part of the job you're doing, and then that line of delineation between those tasks and how they get done, what the procedures are for those. And then when we cross the line of delineation into, okay, we're working around this high voltage battery system, but we're not directly exposed to a live bus bar or a light, and this, now we're digging into my 23 years of experience in industrial automation, where it's like we do as much as we can without exposure to live high voltage. And then when we enter the tasks that are, how do we handle that? And without segueing into that, because then we're kind of diving into like the manufacturing process, I like to wave the white flag that we need to have specific requirements, and we're going to get more into this later in some of our questions when we get into regulation, because while there's a lot of pressure and regulation coming down on carbon emissions and the effects that has on gas-powered vehicles, I'm actually more concerned about the lack of regulation on the standardization on the EV side, and making sure that the vehicles that are being built here are being built safely. They're using manufacturers' components that meet standards, and that the installation itself is meeting a minimum standard. So anyone else got anything they want to say on that, or should we move on?
I think an important part of that with Legacy is teaching people what those dangers are. This question is, we're talking about what the dangers are of an EV. We have been in the industry long enough to know a lot of them, but making sure everyone else knows them as well is a big starting point, because then you can take the proper safety precautions. And that's why the training and stuff is so important in the wider automotive space for EVs, to make sure that people know what they're working with. What do you need to be careful about, and where and how.
Mm-hmm. Well, it's been crazy to me how far the demand for the education goes. We have trained paint manufacturers, because their paint is used on the interior of battery boxes, and when they're trying to explain that to their customers, they need to understand battery chemistry and voltages. Where when we started developing the curriculum, I wasn't thinking about sales reps for a paint, or a motor manufacturer who they understand their motor really well, but they need that foundational knowledge, or insurance adjusters, or it's an industry disruption that affects a lot of people's jobs, not just the automotive technician. So, okay, Kirk, I think this next question's for you. We're going to talk about EV conversion shops. So when you think about an EV conversion shop compared to a conventional hot rod shop, what is the difference and what is similar? And I'm giving this question to you first because your experience in the industry, all your time at AEM and what you've done over your career there, you've had a lot of exposure to different shops. So I think it'd be think people be kind of interested. Is it basically the same? We just need some high voltage tools, or what if if somebody has a shop that does ICE, diesel, and they want to get into this, what are they really looking at?
Sure. So in a lot of ways, they're similar. Tools, fabrication, and fabrication being a big part of what we're talking about. But I think the greatest variance is, one, the level of education, as we're talking about, for understanding what you're looking at. To Eddie's great point, you can't smell this stuff. You have to be aware of it. So you have to be educated. So in addition to that, there's tools. And be prepared if you're stepping into this arena to spend quite a bit of money on crimping tools and crimping hydraulic crimpers for the higher voltage and test equipment. So there's testers that are higher voltage and higher current rating, and then there's also specialty gloves for personal protection that are their absolute requirements. And then the hook to pull something off if there's something does bad is it's non-conductive, that you can just grab a tool real quick and it can just pull a cut loop, or you can snip a cut loop, or you can pull a tool off a pack that's lit up. It's not a 10 millimeter, but it's a 21 millimeter, so it's going to light for a while, and we don't want to burn everything down. So you can have something that's not conductive to knock things off of something bad happening. So the primarily, yeah, it's going to be education and some specialty tools, and education's. They go so close hand in hand, because if you don't have one, if you have the education, don't have the tools, it doesn't work. And if you have the tools and you don't have the education, this is bad. This is, when we talk about education, people think about, is it A, B, or C? In this world, if you don't pick the right answer, it can be really catastrophic. And, in some cases, spectacular, and we can laugh about it, assuming no one gets hurt. We've all burned things, sometimes by design, where we're load testing, but the reality is education's critical to the success process in this case. So that's going to be the largest deviation. And to further, so I've been doing this for a long time on the motorsport side, motorsport electronics and ICE side, and fabrication, motorsport. Safety. There is a massive vacuum for people who understand how EVs work and how the components relate to each other and understand the safety. The vacuum is so frustrating. It is what is holding back this industry. We're having challenges, engineering the complexity out and supply chain, but the other end of it is, man, oh man, is there a vacuum? And we can't afford to say, just because I'm a great ICE guy and I'm a phenomenal tuner and data guy, that doesn't make it okay to jump in. There's steps that are required, that I highly recommend. The legacy program, the EvTech program. There's Switch Labs here. There's Northwood University. There's all sorts of programs out there for education. Some are quicker than the other, but even a short summary in EV 101 that Hypercraft does, that just gets you hooked up with the acronyms, so you understand what we're talking about, is absolutely critical to the process.
Yeah, 100% agree. One thing that I think about with a shop that might not be doing electric vehicle work right now that wants to, is kind of that line of delineation I was talking about a minute ago, where having an area where, when we are going to open something up, or we're really exposed to live high voltage, that area is barricaded off. And I think some shops can struggle if that's not a designated area, because people are coming in and out of the shop, and if it's an area sometimes and other times it's not, and just the confusion around the speed of the day. We're all trying to be as efficient as possible. How do you set up the proper barriers at your facility, so people know, like, when this red blinking light's on, this battery pack is opened up, and there's stay away, but something we recommend. But
Rob, on that, a lot of us have test benches in-house, and majority of us have flashing red lights. When the high voltage comes up, contactors close, there's a flashing yellow light on top of the bench. And then some people are using IDMs to indicate a high voltage breach. But again, you can't do any of that if you don't understand, A, the risk, and B, understand how to work with all that. So it's again, it circles back to education, just understanding how critical it is.
Yeah. All right. Lawson, you ready? I got a good one for you. So I want to dig into the integration I want for everyone who's out here, can you do a quick breakdown? I mean, we could spend a whole day on this. So the challenge is quickly letting people know just like an overview of the separate functioning systems, right? So when you think about an electric vehicle, it's not just an electric motor. It's actually not just a motor and a battery and a charger. So just wow them with all your expertise here.
Yeah, absolutely. I think this stage has spent over a decade, right, on EV systems and how do we make them all work together. Because people know a lot of the big parts of an EV. Most people know an electric motor, right, is what produces the power, gets it down to the wheels. Most people know the battery pack is what stores the energy, and that's how all these systems get power. Some people know things like your onboard charging system that gets power from the wall or from a DC fast charger into the battery pack. But where I see a lot of people are not familiar is how do you make all of these components work together? Because they have requirements. You have to make sure that your battery pack is the right voltage for the motor. You have to make sure that you can control your motor. How do you turn it on? How do you turn it off? How do you know if it's working properly? And that's really a hardware problem to figure out if the components are compatible with each other, but also a software problem to make sure that they can all interact. That's a big thing that I think everyone on this stage has spent a ton of time developing software, which I think surprises a lot of EV builders. An automotive OEM now spends over 50% of their development budget on software. I don't think your average conversion shop or fabricator knows that 50% of their build time might be software if they were to be tackling it from scratch on their own.
That's a good point.
Yeah, and I think that's eye-opening. Some people have learned the hard way. Some of us, I'm sure, have learned the hard way of the amount of software we've had to do. And it's critical. You have to make sure that all these safety systems that we're talking about building into our systems works. How do we monitor them? You're talking about isolation monitoring. How do we indicate that to the user that there's a problem? How do we make sure the car behaves properly at a system level?
Yeah.
It's a really complicated task, and there's not a short answer to that, right? I'm sure there's a day-long course we could just talk about this one thing, but there's a lot to these EV systems and making them work together as a vehicle.
Yeah, and I'll just add to it, I guess, that, watching how quickly, all you guys are in the business of manufacturing and improving these systems. We talked earlier about making them quicker to install. I'm impressed with the speed at which development is happening and how quick you guys are coming out with new stuff that is easier to work with. And as a company that's trying to integrate a lot of different manufacturers' parts, we stay brand agnostic, and I just want to say thank you for all the effort you guys put in. I want to segue into regulation. We talked a little bit about it earlier, and I just think, every one of you guys are involved with EvTech. Legacy's involved with EvTech, and at 4 o'clock we're going to be doing a press release in the Legacy EV booth announcing EvTech and what it is. And it's basically that EV companies in the industry right now who came together to say, as an industry, we need standards. And rather than one company making those standards, we've came together as an industry through this nonprofit to have standards for what does it mean to be a certified EV technician, and what does it mean to have a fully integrated EV powertrain, and what are the safety standards that need to be met for that. I think it's important this early in what's happening that we do that as an industry and do our best to self-regulate in an effort to keep people who understand less about it than we do telling us how we should do it. So do you guys have anything you'd like to add to that as far as standards and where we're headed?
Well, there's one big thing that, I think is a taboo on the EV industry. Every time one of our vehicles catches fire, the press will just destroy you. So I think it's very important, like what Rob says, is we kind of put all our heads together here. We've all made a lot of mistakes. Everybody on the stage has been through a lot of stuff that we don't want you guys to do. We've already made those mistakes, so you don't have to. Some of the reasons we're forming some of these, nonprofits and everything else, so we could all get together. We all know each other here very well. We all talk on the phone. And there's a lot that they know that I don't, and we all come from different places. But think about this very carefully, is if we make a mistake, we're going to be under a microscope. As I said, I do Bonneville all the time. We see cars out there explode, spin out, crash, catch on fire, and everyone's like, whoa, cool. We do it, all of a sudden we're on the front page going, look at those idiots. This is why electric is terrible. This is why EVs are stupid. These are why these guys are clowns. We don't want that. And it's, so once again, when you guys are doing this stuff, look at some of this educational stuff, especially like EvTech and Legacy and everything that we're doing to try to prevent you guys from making these mistakes. We're trying to make better kits for everybody. So, well, two reasons. We like to have products that work. They make the consumer happy. They make us happy. But also safety is a big thing, and not looking like an idiot is another big thing. And I can't pound that into anyone's head enough. There's a lot of gas guys out there. Look at our small little area here. And I guarantee you 75 or 80% of the people out there already hate us. And that's okay, but let's not give them any more ammunition to hate us over it. So, education's key, knowing the stuff inside and out. And if you don't know something, there's a lot more of us in this industry springing up. Ask questions, read articles, just educate yourself on this stuff. And when I started this and you guys started this, we had nowhere to go. We just were tinkering in our garages and shops. Mm-hmm. And here we are. I mean, my fingers are still here. I'm still alive. So,
Chris, you can add something here?
Stop talking about fire.
Let's stop talking about fire.
He's scaring everyone. Like, I've never set a battery pack on fire, like ever. Okay? Like ever. Out of the hundreds and hundreds we've built, we've never had one ever set on fire. And if everyone looks at the way the internal combustion industry went, for over 100 odd years, there's been a lot of development in the industry. You think batteries in the last 20 years have come a really long way. Within the next 5 to 10 years, they will not be able to ever set on fire. The new LFP, the new LMFP battery technology, you can put holes in it. You can do what you want, and they never go over 80 degrees, and they don't set on fire. So I think right now, there's people scared around battery fires. It's not going to be a long-term thing. It's going to be very short-lived, probably 5 more years, then that's it. It won't be a thing anymore.
We'll still have to consider current into the whole thing, though.
Yes.
There's still a lot of current.
True.
So once electricity goes from this side to this side, it makes heat. But that's what we'll have to.
Okay, I got one.
I just wanted to add. No, go ahead. Go ahead.
No, I want to hear you.
I forgot what.
Okay, we're good. I'll give it to you then. Here's my last question, and feel free to circle back if you remember, because again, I hope you guys know how much experience is sitting up here on this stage right now. So it's a great group.
Oh, I know what it was.
Go for it.
Okay. Whew. That was a senior moment. So what's cool, we're talking about battery technology and how quick it's spinning. So some people may say, let's hold off until we see where it's going to wind up. Don't. Because the cool part is every battery ever created is DC. So no matter what happens, if you develop a system and the vehicle is built and you want to do a battery upgrade or a performance mod or anything like that, the battery changes, the system doesn't. So that's really exciting to me. And that's also, I hate to keep circling back to revenue and capital opportunities, but this is an opportunity to upgrade your customer to a new technology. And it's coming fast, man. The amount of money and pressure on the OEMs and the battery manufacturers to create batteries that are substantially more power dense, lighter, and friendly to the earth, and not beholden to just certain countries for their resources is second to none. This is history being made before our eyes. So really exciting stuff, but allows us to capitalize on the new technologies that are on the horizon without having to change the whole system. That was it.
All right, one more question. It's just off the top of your head. Give it to me. Your favorite EV build to date. And don't tell me your car, because
In this show or just in general?
I'm cool with to date, because I probably know about most of them. But I guess if it is here, let everybody know where it's at so they can go check it out.
Okay, it's not my car,
But
I powered it.
okay.
Sorry. I love that Bonneville car, and I hate it so much. It was a really tough challenge, but it was cool to take a vehicle that has got history since 1957 and such a prestigious group of people, the Team Vesco and the Vesco family and land speed racing, something that I've never really gotten involved with, and to watch a piece of history happen and to be a part of it. I mean, to me, that was very, very cool to see and be a part of.
Awesome.
So mine's not here. Mine happened when I was about 8 years old. I had a little RC car, and I really hated how quickly it ran out of juice. So I took another battery pack and soldered it and wired it in. So I had, a pack in parallel, which I thought was really cool. So it went longer. And then I thought, I know in diesels, you put 12 volts in series, you get 24 volts. I wonder what'll happen here. And I did it, and it was awesome. It was twice as fast, but it didn't last real long.
I was going to say.
And the controls didn't work nearly as well, but it was spectacular. I realized what more voltage, more power could mean. So that was a long, long time ago, but it was a lot of fun, and it was something that's always piqued my interest. So I'm glad we are where we are today.
That explains a lot, Kirk.
Well, I think I'm allowed to talk about this car. I think.
Okay.
So the best one that I've seen that none of you will know about is Robert Patterson Batmobile.
Okay.
So we did one electric out of the 4 that we built for running inside a fuel refinery in the US. And that was
That's
one of the coolest cars we've ever built and ever seen, for sure.
Well, now you got to post a picture for us all to see it.
My favorite is actually here. It's going to be the white Porsche that's over there. So it's not, I don't think on the signage, but that is the very first customer car that Ampere EV ever delivered,
okay.
system-wise. And so for us, we had built our DeLorean and some test vehicles, but for that car, the big thing that made it my favorite was it wasn't that we did it. It was that they did it, they being our customer.
Mm-hmm.
And that kind of showed for us in the space that we're all working in, trying to deliver these kits to people, is you no longer has to be us building the cars. It's anyone out there can now convert a car to electric. And that's really made it for me.
No, that's awesome. And I think I'd echo that with, I'm thinking about what we're doing in our booth right now, where we have people who've been through our training, who are repowering a vehicle in our booth live over 4 days. And I can honestly say that would not have been possible 3 years ago. When you talk about the progression of your customers finishing vehicles, so it's exciting times. I hope you guys enjoyed this. I'm getting a finger. Yeah? Okay, I was going to see if anybody caught that. Mine's not, well, okay, I said it had to be built, huh? I have all kinds of stuff up here that will eventually have, wheels spinning that isn't built yet. I was going to give you one of those, but I would have to say the white 66 Caddy. And yes, it's mine, but my grandfather was into Cadillacs, and I grew up around Cadillacs, so it's just like, I love Cadillacs. And so to take that car and then for it to actually be really nice to drive, like the power's better, the driving experience. We talk about the noise, but with that vehicle, it's kind of okay that it's not loud. It's a convertible. It's like therapeutic. It's got the center caps that float. And so there's a bearing in there with a weight, right? And when I'm leaving my neighborhood, I can actually hear the bearing zing, zing, zing. And to your point, Eddie, you never would have heard that with the gas motor in it. But yeah, that's the one that's near and dear to my heart. But I think I think it's going across the block at Barrett Jackson in January. So I don't know if I'll be there. I might stay home. But yeah, I think that's it. I think we should Maverick's giving me the look. So.
I just wanted to say thank you to everybody who showed up for these electrification sessions today. I know I learned a lot getting to hear from all these fellas. There was so much information shared. All of these guys have booths here or are in a booth here. So if you have more questions for them, go talk to their teams or to them and go check out the products that they've developed. It's really an impressive portfolio of awesome products that these guys have put together. Let's give everybody up here a round of applause.